Hi, this is Avin. Welcome to my channel Tricks World. In this video, I'm going to cover Cbse Class 10 Mathematics, Chapter number 8, Trigonometry Exercise 8.1. Many students ask me whenever they begin to solve any trigonometric problem, they become blank. They do not understand what are the steps to be done one by one. One thing we have to remember in our mind that whenever we begin to solve any mathematical problem, we should understand within first 30 seconds what are the necessary steps required to solve this problem. In this video, I am going to give you 30-second tricks so that whenever you begin to solve any problem related to trigonometry, you will come to know that within 30 seconds you will decide what are the actions or what are the necessary steps you are going to apply to solve that problem. To solve exercise 8.1, we must be perfect in trigonometric ratios. What are trigonometric ratios? I have given in detail in my previous video. Trigonometry, it gives relationship between the sides of a right angle triangle and the angles. Ratio, trigonometric ratio means dividing one side of triangle by another side. When we divide one side of a triangle by another side, the ratio what we get, that is called as trigonometric ratio. If you look at the triangle, there are 6 possibilities. That is, we can divide this side by this side, that is one ratio. You can divide this side by this side, that is another ratio. In this way, there are 6 possibilities. The first trigonometric ratio, we name it as sine, second is cos, third is tan, fourth is cot, fifth is cosec, sixth is sec. How to remember all these 6 trigonometric ratios? Here I give you world famous trick. If you remember this sentence, you will be able to memorize and you will be able to write the correct trigonometric ratios for sine, cos, tan, etc. What is that sentence? To remember the trigonometric ratios, we have to remember one statement, that is, some of her children are having trouble over algebra. If we remember this statement, if we remember this sentence, we are going to write the trigonometric ratios. How we can do that? See, we have to consider the first letter of each word. Here S stands for sine. So sine is equal to O stands for opposite side and H stands for hypotenuse. I explain you what is opposite side and what is hypotenuse. If you look at the triangle ABC, if we are standing at angle A and we are observing this triangle from the angle A, the side BC is opposite to angle A. Therefore, side BC is called as opposite side. And this opposite side, sometimes we can call it as perpendicular side. The side BC, we can call it as opposite side, and some people, they also call it as perpendicular side because it is perpendicular to base. Then the side AB is adjacent side. Why we call it as adjacent side? Because the side AB is just beside, it starts from the angle A, just beside angle A. Therefore, it is called as adjacent side. And this side AB is also known as base. Some people call it as adjacent side and some people call it as base. And the third side, which is opposite to 90 degree, that is called as hypotenuse. Sine means opposite side by hypotenuse. How we came to know sine is opposite upon hypotenuse? From this statement, sum of her. This sum of her gives sine ratio. S stands for sine, O stands for opposite side, H stands for hypotenuse. The next ratio that is called as Cos ratio. Cos, this C represent cos and A represents adjacent side and H represents hypotenuse. That means cos is ratio of adjacent side and hypotenuse. We can write in the place of adjacent side, we can write AB, and in the place of hypotenuse, we can also write AC. Therefore, cos ratio is nothing but adjacent side upon hypotenuse. How we came to know? How we can remember? By remembering children are having. Then the third ratio, here T stands for tan. T stands for tan. Tan, and O is opposite side again, and A is adjacent side. When we divide opposite side by adjacent side, the ratio obtained is given a name tan. Therefore, tan is nothing but opposite upon adjacent. Here, from this statement, we have remembered, we can recall three trigonometric ratios: sine, cos, tan. Once again, I repeat, we have to remember some of her children are having trouble over algebra. Sum of her gives sine ratio opposite upon hypotenuse. Children are having gives second ratio cos equal to adjacent upon hypotenuse. Trouble over algebra, it gives the third ratio tan equal to opposite side divided by adjacent side. When we remember these three ratio, remaining three ratio, easily we can develop from sine. We can develop the next ratio cosec. Cosec is nothing but 1 upon sine, that is inverse of sine. Simply we have to invert the ratio of sine, that is cosec equal to inversion of sine, that is hypotenuse divided by opposite side. This is the fourth ratio. Fifth ratio we can get by inverting. I write here inverting, that is cos, that is called as sec ratio. Sec equal to 1 upon cos. That means inversion of cos. Inverse of cos is, inverse means we have to invert, that is hypotenuse divided by adjacent side. And the last ratio we can obtain by inverting tan. That ratio is called as cot ratio. Cot is nothing but 1 upon tan. We have to invert tan. Tan is opposite upon adjacent side. We have to invert it. That means adjacent side divided by opposite side. These are the 6 ratios we have to remember. Then and then only we can solve the numericals related to trigonometry very easily. When we see the question within 30 seconds, we should be able to understand what are the necessary steps we have to carry out to get this answer. Now I give you the magical trick that will help you to solve the numerical. Now let us solve exercise 8.1, question number 1. In triangle ABC, right angled at B, the length of AB is 24 cm and the length of BC is 7 cm. We have to find sine, cos, sine C, cos C. In this question, they have asked to find the ratio of sine and cos. We can find ratios of trigonometric angles only when we know all three sides of the given triangle. Here they have given the length of two sides, therefore the third side should be calculated first by using Pythagoras theorem. Then we can find out the ratio of these trigonometric angles. So what is the trick to solve this numerical? First step is we have to use Pythagoras theorem. Then we have to find the ratios. Now within 30 seconds we can solve this sum. We know now what is to be done next. We have to use first Pythagoras theorem to find out the third side. Once we know all three sides, then we can find the ratios of trigonometric angles. Let us find the third side by using Pythagoras theorem. By using Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square equal to sum of squares of remaining two sides, that is BC square plus AB square. Now AC square equal to BC square is 7 centimeter square, that is 7 square. Then AB square is 24 square. We know that 7 square is 49 and 24 square is 576. How we can find out the square of 24? We have to multiply 24 two times. Then we get 576. If we add these two, it will come to 625. This is the value for AC square. If we want AC value, we have to take square root at both sides. AC equal to square root of 625, that is 25 centimeters. So this is the length of AC. Now we know the values of all three sides. Now it is easy to find trigonometric ratio. Now let us find out sine A value. We know that sine is nothing but opposite side divided by hypotenuse. Sine A means we have to observe the angle. We have to observe this triangle from angle A. Therefore, this side becomes opposite side and this is hypotenuse and this side is adjacent side. So we know that the ratio for sine A is opposite side upon hypotenuse. Opposite side is BC and hypotenuse is AC. Let us substitute the values. BC is 7 and hypotenuse is 25. Now cos A. In the previous video, I have given the trigonometric ratios. In that video, I have told you that cos A is nothing but adjacent side divided by hypotenuse. Here, adjacent side is AB, hypotenuse is AC, that is equal to 24 centimeter divided by 25 centimeter. Centimeter, they get cancelled, we get 24 upon 25. This is the value for cos A. Now let us find the value for sin C and cos C. Sin C. Here we have to observe the given triangle from angle C. From here we have to observe, therefore this side becomes opposite side and this side become adjacent side. This is adjacent side and this is opposite side and this is hypotenuse. Therefore sin C means what? Opposite side divided by hypotenuse. In this case, opposite side is AB and hypotenuse is AC. Substituting the value, AB is 24 centimeter and hypotenuse is 25 centimeter. So we get sin C equal to 24 upon 25. Let us calculate cos C. We have to observe this triangle from angle C. Therefore, this is opposite side, this is adjacent side, and this is hypotenuse. And we know the ratio for cos C is adjacent side divided by hypotenuse. Adjacent side is BC, hypotenuse is AC. The value of BC is 7 cm and the value of hypotenuse is 25 cm. Therefore, the cos C value is 7 upon 25. Now I give you 30-second trick for this numerical. What is given here? Two sides are given, and what is asked? Trigonometric ratios. To find the trigonometric ratios, we should know all three sides. So, two sides are given. Third side must be calculated by using Pythagoras Theorem. And then we have to take ratios. So this is the trick that helps you to understand how to solve this numerical. What is the first step? Pythagoras Theorem. What is the second step? To find the ratios. Next time when you do revision, you need not have to read all these steps to remember this numerical. Just you have to read these hints. These hints will help you how to solve such type of questions. It saves your time. Whenever you revise this numerical, don't read all the steps. It consumes more time. Just read the question and see this hint. Pythagoras Theorem, ratios. Apply the Pythagoras Theorem and then find the ratios of trigonometric angles. Question number 2. In the figure, triangle PQR, length of PQ is 12 cm. It is given. The length of PR side is 13 cm. It is also given. We have to find tan P minus cot R value. What is the trick again? Two sides are given and we have to find the ratios, trigonometric ratios. That means we must know before we proceed all three sides of the given triangle. Therefore, two sides are already given. Third side can be calculated by using Pythagoras Theorem. Then we have to find the ratio of required trigonometric ratios. So, what is the hint for this? Apply Pythagoras Theorem, then find the ratios. This is the 30-second trick that helps you to solve this numerical. Let us proceed. Let us apply the Pythagoras Theorem and find the third side. In this triangle, in triangle PQR, it is right angled at angle Q. By using Pythagoras Theorem, hypotenuse square PR square equal to sum of squares of remaining two sides, that is PQ square plus QR square. Here PR square is 13 square, PQ is 12, that is 12 square. We have to find QR square. So I write as it is. 13 square is 169. 12 square is 144. QR square. We have to find QR square. So I shift this 144 this side. That becomes 169 minus 144. That means QR square. Therefore, QR square equal to 25. 169 minus 144, that is 25. Therefore, taking the square root on both sides, we get 5 centimeter. Therefore, the length of QR is now 5 centimeter. 5 centimeter. Now, let us find the ratio for tan P, then cot R. Now, let us find tan P value, then cot R value, then we will find tan P minus cot R. Let us find tan P. We know that we have to observe the triangle from the angle P. We know that tan means opposite side divided by adjacent side. From angle P, QR is opposite side. From angle P, QR is opposite side and PQ is adjacent side. Therefore, tan P is equal to opposite side divided by hypotenuse. That means QR upon PQ. QR upon PQ. That is equal to QR is 5 centimeter and PQ is 12 centimeter. This is, I call it as equation 1. Now let us find cot R value. Cot R. Now we have to observe this triangle from angle R. We know that cot means adjacent side divided by opposite side. Therefore, from angle R, this is adjacent side and this is opposite side. Therefore, cot R means adjacent side divided by opposite side. Adjacent side is QR divided by opposite side is PQ. QR is 5 centimeter and PQ is 12 centimeter. I call it as equation 2. Now, from equation 1 and 2, we have to find tan P minus cot R. Now we know the value of tan P and we also know value of cot R. So, we can now find out tan P minus cot R equal to tan P is 5 minus 12 minus cot R is also 5 upon 12. 5 upon 12 minus 5 upon 12, they cancel and we get 0. This is the value for tan P minus cot R is equal to 0. Tan P minus cot R is equal to 0. How we solve this numerical? Two sides are given and we have to find the ratio of some trigonometry. So we have found out the third side by using Pythagoras Theorem. Then we have found out the ratio of trigonometric angles. Then we have substituted in required equation and we got the answer. Question number 3. If sin A equal to 3 upon 4, calculate cos A and tan A values. In this question, indirectly he has given the values of two sides of a right angle triangle and we have to find the trigonometric ratio. That means first thing we have to find the third side by using Pythagoras Theorem. Then we have to find the ratios. How we can do this? We have to draw a triangle I give the names triangle ABC, which is right angle at angle B. We know that sin A means opposite side upon hypotenuse. We have to consider this triangle from angle A. This BC side is opposite side and this AC is hypotenuse. What is the value? 3 upon 4. This is given. Sin A equal to 3 upon 4 given. That means opposite side is 3 units. We call it as K. K is a real number. Then hypotenuse is 4k. If the length of the sides of triangle are given in centimeter, at that time we need not have to consider k. Units are not given, then we have to consider it as k units. K is a real number. Now let us apply the Pythagoras theorem. By Pythagoras theorem, AC square, that is hypotenuse square, is equal to sum of remaining squares of remaining two sides. Sum of squares of remaining two sides, that is AB square. Now AC is 4, therefore it is 4 square, and BC is 3. We will also take K, 3k square plus AB square. Now 4 square is 16, k square is k square, equal to 3 square is 9, k square is k square plus AB square. Now let us find the value of AB. Therefore AB square equal to, I shift this 9 square this side, that becomes 16k square minus 9k square, that means 16k square minus 9k square, that is equal to 7k square. Now we have to find the AB value. Therefore taking square root at both sides, therefore AB equal to, square root of 7 is not possible, therefore I write it in the square root sign, and square root of k square is k. Therefore the length of AB equal to root 7k. This is root 7k. Now it is easy to find the ratio for cos A and tan A. Now let us find the value for cos A. We know the ratio for cos A is adjacent side upon hypotenuse. We have to observe the triangle from angle A, that is opposite side is BC, adjacent side is AB, and hypotenuse is AC. So adjacent side, that is AB, upon hypotenuse is AC, that is equal to, AB is root 7k divided by AC is 4k. K get cancelled, so we get root 7 upon 4. This is the value for cos A. Now let us find the value for tan A. That is tan A equal to opposite side upon adjacent side, opposite side upon adjacent side. Opposite side is BC and adjacent side is AB. Let us substitute the value for BC, that is 3k. Let us put the value for AB, that is root 7k. Again k get cancelled, we get 3 upon root 7 is the value for tan A. In this way, in this sum, we have found out the value for cos A and tan A. What is the trick for this? Use Pythagoras theorem, find the third side, then find the required ratio. That's it. Question number 4. In question number 4, they have given 15 cot A equal to 8. Find sin A and sec A values. What is the trick for this? We have to find sin A and sec A. That means we have to find the ratios. And we know that to find the ratios, we should know all three sides of the given triangle. And in this example, they have not given directly the two sides. They have given indirectly two sides. They have given 15 cot A equal to 8. From this we can get cot A equal to 8 divided by 15. That means we get the values for two sides, and third side can be calculated by using the Pythagoras. Therefore, this problem also can be solved by using Pythagoras theorem, then using the ratios. Let us solve this. Answer: consider a triangle ABC, which is right angle at angle B. Now we have 15 cot A equal to 8. That means what? Cot A equal to 8 divided by 15. And we know that the ratio cot means adjacent side divided by opposite side. From angle A, the side AB is adjacent side, that is of value 8K, and from angle A, BC is opposite side, its value is 15, and we take it as 15 units, that is 15K, where K is a real number. Now, by using Pythagoras theorem, hypotenuse square equal to AC square equal to square of sums of remaining two sides, that is BC square and AB square. Now AC square equal to BC is nothing but 15K square plus AB is 8K bracket square. Let us simplify. 15 square is 225 and square of K is K square, and here 64K square. If we add these two values, it will become 289K square. Now taking square root at both sides, so we get AC equal to square root of 289 is nothing but 17, and square root of K square is K. AC equal to 17K, that is 17K. Now we know the length of all three sides. Now sin A equal to sin A. We know the ratio for sin A is opposite side upon hypotenuse. Opposite side is BC. Hypotenuse is AC. That is equal to BC is 15K and hypotenuse is 17K. KK get cancelled. Here we get 15 divided by 17. This is the value of sin A. Let us find the value for sec A. Sec A is nothing but hypotenuse divided by adjacent side. That is equal to hypotenuse is AC. Adjacent side is AB. That is equal to 17K divided by 8K. KK get cancelled. 17 divided by 8. This is the value of sec A. Sec A equal to 17 divided by 8. Once again, I make a recap of this question. They have given 15 cot A equal to 8. Find sin A, sec A. Indirectly, they have given the ratio of cot A, that is cot A equal to, after shifting 15 to right side, it will become 8 upon 15. Cot A equal to 8 upon 15. That means we know now two sides. Third side can be found out by using Pythagoras theorem. Then we have found out the ratio of sin A and sec A. Question number 5. Given that sec theta equal to 13 upon 12, find other trigonometric ratios. We can decide how to find the answer for this question within 30 seconds. How? Here we have to find out trigonometric ratios. That means we should know all three sides of given triangle. Here they have given sec theta 13/12, means they have given the values or length of two sides. Third side can be found out by using Pythagoras theorem. So use, what is the first step? Apply the Pythagoras theorem, then find the ratios for other trigonometric angles. Let us do it. Answer. I consider a triangle. Consider a triangle A, B, C. Angle A is of theta degree. Then from theta angle, this side is opposite side, this side is adjacent side, and this side AC is opposite to 90 degree. That means it is hypotenuse. Now what is given? Sec theta is given, that is 13/12. We know that sec theta is nothing but hypotenuse divided by adjacent side. Here hypotenuse is 13, adjacent side is 12. Here hypotenuse is 13K and adjacent side is 12K. Now by using Pythagoras theorem, hypotenuse square equal to, that is AC square equal to sum of squares of remaining two sides, that is AB square plus BC square. Now AC square is 13K whole bracket square and AB is 12K whole bracket square plus BC square. Now 13 square is 169, K square is K square, and 12 square is 144, K square plus BC square. In order to find the value of BC, I shift 144 this side. That means we get BC square equal to 169 K square minus 144 K square, that is equal to 25 K square, that is equal to 25 K square. And if we find square root of both sides, we get BC equal to 5 K. Now we know the length of all three sides of the triangle. Now we know the length of all three sides, that is BC is 5K. Now we know the length of all three sides. Now let us find remaining trigonometric values for angle theta. The first is sin theta. We know that sin theta is nothing but opposite side upon hypotenuse. Here opposite side is BC, hypotenuse is AC, that is equal to BC is 5K and hypotenuse is 13K. KK get cancelled. We get 5/13. This is the ratio for sin theta. Now let us find cos theta. Now let us find cos theta. We know that the ratio for cos theta is adjacent side divided by hypotenuse. Adjacent side is AB, hypotenuse is AC, AB is 12K, hypotenuse is 13K, KK get cancelled, we get 12/13. This is the value for cos theta. Now let us find next trigonometric ratio, tan theta. Tan theta is nothing but sin theta divided by cos theta. In other words, we can say that opposite side upon adjacent side. We know that opposite side is BC, adjacent side is AB, BC is 5K, AB is 12K, K get cancelled, 5 upon 12. This is the value for tan theta. Now for cot theta. Cot theta is nothing but 1 upon tan theta. That is 1 divided by tan theta means adjacent side divided by opposite side. Adjacent side is AB. Opposite side is BC. That is equal to 12K divided by 5K. These get cancelled. We get 12 upon 5. This is the value for cot theta. Now last, cosec theta. Cosec theta is nothing but 1 upon sin theta. That is equal to 1 upon sin theta means what? Opposite side upon hypotenuse. Hypotenuse will come to numerator. So we get hypotenuse divided by opposite side. Hypotenuse is AC and opposite side is BC. The value of AC is equal to 13K and the value of BC is 5K. These get cancelled. We get 13 upon 5. This is the value for cosec theta. In this way, we have found out remaining trigonometric ratios. In this video, out of 10 questions given in the exercise 8.1, I have solved 5 questions. Remaining 5 questions, I will solve it in part 2. I hope you have understood the concept. I hope you have enjoyed this video. I am thankful to YouTube and millions of YouTube viewers. Please subscribe, share and press the bell icon and leave a comment. This is Avin. Thank you so much.